right? It's all about application. Integration is net change is saying, let's find a final amount given an initial amount and given a rate. True? So even though this is true, wait, hold on. This isn't net change. Well, yeah, it is. I mean, what is this really? Yeah, I was just thinking it was fundamental theorem of calculus, right? Right? But does it show displacement? How is Aryan also right? Isn't a change in the same thing as displacement? Right? From FTC, but what are we, even though it is FTC, even though it does show displacement using integration, a definite integral of the rate of change, what are we used to from our forever card as far as the actual formula for net change? It's rearranged. What do we usually write for integration as net change? Yeah. Plus displacement is equal to. But we also don't usually put capital F prime. Even though it is a rate, what do we normally put in there? Because we have our capital F as our antiderivative, and so all of this is based on F being the rate of change, right? Does that make sense? So initial plus displacement ends up with final, and that makes sense because if you think of where you started and think of the overall effect of your entire journey, whatever it was, well, then you're going to end up with wherever you ended. So if we put words to it, which should be in our forever card, I don't remember if we totally did put words to this one, but final amount is equal to initial amount plus do displacement, but displacement is very particular to what context? Yeah, displacement we could put for this integral as far as the description, but that's actually very, very specific to what context, what type of application. Motion. And this could be all sorts of things besides motion, right? Remember all of our makeup, whatever's going to be on the AP last year? Change. Right? Change in amount. Because we talk about displacement and it's how much a biscuit has cooled when it got out of the oven, like that's kind of weird and awkward, at least in my mind. Maybe in your mind you're like, no, it's displacement. Change is the long story short of what's going on. So if we had something like, ooh, a chemical flow, that's not motion, but it has motion, right? What are they asking for? Chemical flows into a storage tank at a rate of 100 plus 3t, 180 plus 3t liters per minute, between 0 and 60. This is only asking for what? At or the over? Ooh, do you remember that from last year? The at or the over? Pause. Let's go back for just 1 second. What do I mean by at and over in context of these? And over an amount of time is using how many times? Is it at one time or is it over a time interval? So which one is over and which one is at? This one is over what's going on over a certain passage of time, right? What's this one finding? What's the amount at? Does that make sense? So over is just going to be the definite integral. At, when we're dealing with rate, because we have to go back to amount, we know that. Over is going to be the definite integral. At is going to be, ooh, what's the initial? Does that make sense? Okay, so when I said over or at, who's this guy? Over. Oh, well that's easy, because all we have to do for over is the definite integral from? Because when it says the first 20, what if it was to say the last 20? 40 to 60, right? Does that make sense? Okay. But 0 to 20 of my... Is the point of the section for me to teach you how to do integrals? Nope. So, what's your label going to be? We could call this, if you wanted to, CFT. I like C of t, but let's do change in C. There you go. Whatever it is, after you guys solve. Chemical flows into at a rate of, so that'd be like your C prime of t. Yeah, that works. That could be your delta C. So it'd be C of 20 minus C of 0 after you integrate. Does that make sense? More than one. I don't mean that in like a mean way. I just mean like I'm sure it was all over the place. I think one of the most common topics that kind of goes unnoticed is integration as net change. Because it's usually asked for quite a few times, but it's not always as obvious. Because sometimes it's an over, sometimes it's an at. Oh, you're thinking the FRQs. Sorry, I was thinking the whole thing. Kind of fun, because every time... I'm lucky teaching in California because the time you are just about to start your FRQs, or no, when you're in your FRQs, I see the memes from the East Coast. I'm like, they should know how to do that. Let's see the questions. I can't see the questions. Well, yeah, because of the time difference. So they're all memeing about it, right? They're all posting about it. What? Go ahead.
Apparently last year the WAP I'm prepared so much for that one.
Ah! Ready, set, go. Okay, pause. No discussion. Let's see if you guys can ace this one. Go. Do the calculator? No. But we'll see if you guys can do arithmetic. Well, the numbers are big, so you're going to freak out a little bit, but the integral is completely able to be integrated by hand. Customers arriving at a counter, would the AP ever do something that weird? Yeah, totally. Was last year the 1 over pi is a coefficient. Unless you want to do coefficient, but just an over or not? I didn't answer. Which one will you follow of Maggie's answers? One of your answers. Is it asking how many customers are in the store, or just how many have come during the time? Over. It has the word over. It's the word over. Well, because I didn't want to just tell them the answer. Let's see if you can approximate. This is technically a calculator problem, but that's no fun.
No, it's like 19.2. No, it's going to be like 19.
I don't know.
Between 0 and 1? No. Justin, she's saying sine times 6 pi. There you go. So this is going to be, so Riley, what happens if you do sine of 60 over pi alone? There you go. Oh, I think you said it wasn't 0.2. Yeah, that makes sense. Yeah, it'd be in the first quadrant. It's a little bit past 6 pi. A little bit past 18, 6 pi-ish. There you go. Anyway, what do you end up with? Wait, are you? Just solve the definite integral. Did we do something wrong with the u sub? Do you guys do the same u sub as I did?
I didn't have the times pi because I just pulled it out.
Oh, that's funny. Integrating cosine is a positive. How did you guys not catch that? You silly goofs. There you go. So 720 plus 4-ish, is that what you said? It'd be 725.
Yeah.
You guys integrated correctly, though, right? You didn't put minus?
No, I took
Oh, there you go. There you go. So it was plus, not minus. Oh.
Is that it?
du is equal to 1 over pi dx, right? So when you have to get the x by itself, you just move
Let's do this one first. Homework helps. Now both of those were overs, right? Could you very well have at? Yeah, you could. What's going to be different at? Initial plus the change. But what's going on in this example? A 10-mile stretch of a couple years since there was an accumulation problem like this before. On the North by colonies of pocket gophers. Along the road, the density of the gopher population is 500 per square mile. The density increases linearly until it reaches 2,000 per square mile. The density is increasing? Density is the original quantity? Gophers per square mile is the original quantity? Until it reaches 2,000 square miles from the road. Find the total gophers in this stretch of land that is 10 miles long and 3 miles wide. This is an integration, is that change? It's integration, it's accumulation. How do we find gophers? Oh, we just integrate gophers per square mile. No.
It's 2,000 per square mile, right?
Why would it make sense that there would be a heavier density of gophers the farther away you get from the road? Well, maybe roadkill and then less distraction. Like what gophers are like, yay, I want to settle here. There's tons of cars whizzing by. So it makes sense the density wouldn't be the exact same everywhere, right? What else is important? Holy. So what would d prime equal? This is my road, and here's all the gophers. The gophers right here are 500 per square mile, and the density increases linearly, like an increase, 1,000 out here. So I'm asking, how can we write d prime? Last year there was a wind chill. Same thing here. What's d prime? Is it up to 2,000 over 1? It gets up to 2,000, starting from? Ooh, at 3. So hold on, maybe 3 what? Yeah, so you could think about it that way. You have 0, 500 when you're talking about d prime, and then you have 3, 2,000. So 0 miles from the road, and then 3 miles from the road. Slope of a line? Rise over run?
Yeah, that's what I think.
How do we do rise over run? So what is my slope? It's not 2,000. 1,500 over 3, so therefore the slope is going to be 500. Does that work? So that's my d prime of n. Why do we need integration? Don't we want gophers per square mile times square mile? And then we'll get gophers, right? How are we going to find square mile? We know the distance. That's not the problem. Or we know the coverage. We know where the gophers are. We can multiply by 30 easy, but what do we multiply? 500? Well, it's not that the whole time. 2,000? Well, it's not that the whole time. We need to accumulate all the density together to then multiply by 30. So how do we accumulate the 500s all the way up to the 2,000s? Integration. So what are we going to integrate? Definite, we need the over. What are our bounds going to be? 0 to 3. Why? Because wasn't everything, Kathy and Riley, everything dependent on the mileage? Like how many miles away from the road? When they were thinking out slope, we knew miles and we knew gopher density, right? 0 to 3. What am I going to put into my integrand? Yeah, my 500 plus 500. You could do m if you want. And everything's in terms of the miles per road, right? Okay, so now what do I get? Mm-hmm. Since it's definite, we don't need to worry about the plus c. Good. Can we make our lives a little bit easier by pulling out a 250m? Now what? So we get 750 times 5 minus 0 times 2. So it's my accumulation. What is that? That's adding together, accumulating, which is what integration does. Last year we also had something to do with temperature outside and having to heat or cool a house, and we had to accumulate all the different temperatures that the weather went through. That's an accumulation problem too. It's hard because what you're being given is wait, per square mile, and let's go back. No, not acceleration. Density is own rate of change. Does that kind of make sense? Wait, what is this? All the densities put together. All the densities are being measured by what unit? Yeah. Aren't always as many gophers, the density isn't always as thick every place, but I now know these clues. It starts at 500, goes to 2,000. Okay, that's the density. So I can just take that density, which puts it all together, and then multiply by 30 square miles, and all of a sudden I have how many gophers? I don't know, a lot. What do we have? 5 and 1 and 22 and 2 and 9 and 11. Then we have 2 zeros. Is that right? They need to get some coyotes in there. Hopefully they don't have rabies. It's a lot of gophers. I'm not saying they're all this bad. This is example 8, so there's a lot of examples before this, right? But what is the key word, even though what's actually in here? What concept was it testing you on? Whether or not you could use integrals to accumulating amounts that change over time. What can change over time? Density. What can change over time? A lot of things with very weird units that you might not always be ready for. Does that kind of make sense? Yeah.
So I'm just a little confused on the 750 value. So is that a glorified average, or is it
Yes.
Okay.
Accumulation is, but it's a perfect average. Does that make sense? So I wouldn't say an average. I would say it's a perfect accumulation, which in your mind would be similar to the idea of an average. Does that make sense? But with the integration, it's perfect. Yeah. Okay. Well, it's as perfect as the model that defined how the densities change. Does that make sense? So if that model wasn't perfect, this is perfect based on what was given to us, but the problem with math in the real world is, it tends to model closely models, and so then you get some variance. Okay. Like if you were to go out and kill every gopher and then scan for life and there were none left, would you necessarily have 112,500? Maybe, maybe not. Well, that was a little bit dark. Okay, how about this one? Because generally with electricity, I don't know, Edison and whatnot, when they measure, they do it per day. And so they're measuring how much you use per day. Yeah. Isn't a lot of this just trying to teach you what's about to come, what the labels mean? Right? Do you have to do average? Isn't the rate of the average consumption already? Isn't this the measurement of the rate of something that is already the average? Do you need to do anything to average it further? So why am I throwing in an integral? Because we have the rate and they want the non-rate. technically, right? So they want the box where I have the box prime. Well, how do they go backwards? Integration. So I can t of t, but what would my bounds be? T is time, and time according to is hours, and hours in a day is... Really? Yeah. Because of the daily is saying for a whole day. So from beginning to end of a day. Do you see how forever cards are good, but sometimes they'll screw you up? Average. Oh, average value. Average rate. Average something. But it was an average. Just think rate and non-rate. Oh, sweet. Let's integrate. So y 0 to 24, because it said daily. So daily. Okay, why am I showing you those examples? Because how long was our notes for these sections? For this section? Short. The idea is short. The idea is give me a rate, I'll integrate, and I'll get you how things changed. And I can use how things changed, adding to where it started to tell you where it ended. And the idea isn't that bad, especially if you can use your calculator, which you can have it available. Don't like totally forget how to solve integrals by hand. But could the ideas get hard? Maybe. Do I have anything else? I have like the packet stuff. That one wasn't too bad packet-wise. That one wasn't, ooh, trapezoidal sum. Go team. That's an over, though, between. Is there an at? Average temperature? That's using your actual average. Oh, hey, no wonder I had it in my head. There you go. This is the example I was talking about just a second ago from your packet last year. Because what is this function modeling? The temperature outside. But the problem is, average temperature, you have temperature, that would be average value. This is just what is the temperature. I need to average it. Oh, 1 over b minus a, integral from a to b. But why does this one go doing some crazy stuff? Because the air conditioner only cools the house whenever the outside temperature was at or above 78. When could that happen? When it was 79. When else? When it was 80. When else? When it was this entire time. But is the temperature always just 78? No. So is it necessarily having to cool it over? Oh. Now, this one was just saying when does it cool? And if you guys graph the function and graph 78, you're like, oh, it's going to be hotter than 78 from this time to this time, so the air conditioner is going to be on from this time to this time. That's all this one was asking. But then this one starts talking about the total cost. If I can get it, there you go. That didn't hurt you at all. The total cost. Do you see that word? Do we need to get better at that word? All right, we're going to see how the homework goes. It is due tomorrow. See how it goes. Some of it will be easy. Have your calculator close. The point of this section is not that you can integrate, although hopefully you don't forget. Sound good? There are a few of you guys' homework spirals up here if you didn't already get them, but I think most of you already did.